we'll be covering different topics, not so much Mars this month, but Venus and more deep space things, and in general, the role of disruptive technologies. So first we'll talk about the robotic missions to Venus. They've been announced by NASA and others. NASA in particular announced 2 of them, which are going to launch around 2029. And those are the first missions that have been sent by the US in over 30 years, except for flyby missions, where we got a gravity assist really to go to somewhere further out actually in the solar system. The 2 projects are called Da Vinci Plus and Veritas. They made up incredibly convoluted acronyms for them, which don't really matter. They obviously were just acronyms. But there are 2 different purposes. One of them is focusing on the atmosphere, that's Da Vinci. The other one is focusing on topographic maps, that's Veritas. Da Vinci is going to orbit, but then it will also parachute a probe, which is a 3-foot titanium sphere. It'll parachute that down to the surface. It'll take about an hour to get there. That probe will only last about an hour and a half before the conditions of Venus overcome it. The problem, as I indicated on the slide to the right here, the atmosphere is about 90 times thicker than Earth's, which means the pressure is about 90 times higher than Earth's, 900 degrees at the surface, and a lot of sulfuric acid. So it's not really a friendly place. You're not going there for weekends for a long time. But what they're hoping to determine is more information about how the atmosphere evolved, try to figure out if it ever had an ocean. They're going to be looking for the evidence of phosphine, which had been considered a biomarker, meaning there might be life there. That turned out to be kind of controversial. It was a theory for a while. It's pretty much been discredited, but there's enough of a question that they made a point to, in fact, add some extra capabilities to make sure to look for phosphine. Veritas is updating the topographic maps. They're looking for geological activity like volcanoes and land movement. Now, scientists currently don't really think that there's plate tectonics going on in Venus, at least now. But yet they do think there is some land movement in some form, in some big chunks. And so they're going to be comparing previous data to the new data to try to see how much the land really moves around, if at all. Now, other probes have been announced. The European Space Agency, ESA, they have a similar mission which they want to send in 2031, which will just be an orbiter, not a probe that descends to the surface, but the same kind of goals, basically. Now, what's interesting is that Rocket Lab, which is a small company originally out of New Zealand, now a US company, they're talking about doing a private mission using their Photon spacecraft, and that would be in 2023. There's a picture of that to the right here. They only recently started using this, what they call their line, Photon craft. For low Earth orbit projects, the configuration is quite different, but this is what they call their interplanetary configuration. Which may sound rather ambitious for a small private company, but they're planning on doing it. They'll orbit and they'll drop a probe and looking for that phosphine biomarker. You might think that sounds crazy, but then you put it in perspective. They've already got contracts with NASA for taking essentially the same Photon spacecraft and orbiting the moon with it. They're going to be putting that in the same orbit that this future gateway would have, assuming that ever actually happens. And then they've also just recently announced that NASA also has contracted them to go to Mars with this. Now, in this case, they won't be launching with their own rocket. NASA will provide that one way or another, but they are going to send their spacecraft, this particular one, to orbit Mars and use it for analyzing the atmosphere and so on. Why now, after 30 years? A couple of reasons, really. One has been all the recent emphasis on climate change. There's always been a lot of interest in Venus because of that. And you're saying, well, it's a pretty much like an Earth-like planet. It's closer to the sun, but it's just a heck of a lot hotter. So people wonder, well, what went wrong? And so there's that climate change emphasis. And the other thing is the recent excitement over the possibility of there being life there, not on the surface where it's too miserable, but up in the clouds. So anyway, both of those things contributed, and now we have multiple missions headed to Venus. Closer to Earth, of course, most people have heard about the battle of the billionaires with Virgin Galactic and Blue Origin, both planning on launches very, very soon, tomorrow, in the case of Virgin Galactic. Richard Branson is still expected to go up along with 3 other employees of Virgin Galactic. This will be their first launch with passengers, and then they always had 2 pilots. So they've had piloted missions before. they haven't done that much testing. And unfortunately, back in 2014, in fact, they lost a pilot. The craft broke up due to a pilot error. So, but anyway, he's going up. This is kind of like the old, I've always heard these stories about World War II submarines. And when the US launched a new submarine, they always said the welders had to go down in the initial test. And that was to encourage them to make sure they did a good job. And that's essentially what both Richard Branson and Jeff Bezos are doing in these launches. They're showing that it's safe enough that even they're willing to go. The Virgin Galactic case, it's about a 2-hour ride. Now, most of that is actually in a carrier aircraft. Their system is you go up in a regular plane, it drops off the rocket then shoots up. You end up with about 4 or maybe 5 minutes of weightlessness on that rocket trajectory. It's a rocket plane shown to the right here, which then lands back in their New Mexico spaceport. Blue Origin takes a very different approach, a more conventional one, actually. This is with their rocket called New Shepard, which is shown down here in the right. And this is really their first launch with people. They've done maybe 15 launches before, but they've never done one with people before. And here the first time, they're going to be taking up Jeff Bezos himself, along with his brother. You probably saw it in the news, but there's an 82-year-old woman named Wally Funk who trained as an astronaut years and years ago, but then was never actually allowed to go to space because they weren't really sending women to space back in those old days. And then the fourth person is someone who, in a charity auction, decided to pay $28 million. That charity, by the way, is to further STEM education. It's a side project of Blue Origin. We still don't know who that person is, but somebody thought it was worth 28 million. For 28 million, they could practically go to the space station. So they definitely overpaid for this. I guess they wanted to go on a ride with Jeff Bezos. It's about a 10-minute ride altogether. It's completely automated. There's no pilots. And you get about 3 minutes of weightlessness out of that. Now they're really, those two are the head-on competitors. They're doing essentially the same experience. Then there's a couple of other ones you might consider if you don't have quite the amount of money that it takes. We've covered this before, but there's a balloon called Spaceship Neptune from a company called Space Perspectives. They just tested a small, kind of a scaled back version of it on June 18th. And it will, when they do the full-sized version, go up about 19 miles, but it's a gentle 6-hour flight. You're not pinned down with 3G forces like you get on the rockets. You have a lot more time, but you're only going up 19 miles. But that's enough to see the curvature of the Earth. You get a very different view, pretty much like the view from space further up. And it does have a bathroom if you're going 6 hours. They do have that. The others don't. A bathroom with windows so you get a good view while you're using it. And they will be starting, they did start ticket sales starting in 2024. So if you want to put down your $1,000 deposit, you can get that. It's only half the price of the others, so it's kind of a bargain. It's about $125,000. The markets for these things in general, for the rocket-based ones, are tourism, of course, but actually also for astronaut training, some short research experiments. Actually, both Virgin Galactic and Blue Origin have carried NASA payloads. They're very short trips, but there have been times when they've used that. So there is more to it than just space tourism, but tourism is the main focus. So that was suborbital. Remember, both of those just go up and come right back down. Now there's also, of course, a very active market going on right now for space tourism that is orbital, meaning you make at least one orbit, so you're going up quite a bit higher. It actually takes a lot more fuel to get up that much higher. There's a company out of Houston called Axiom that has done some of this before. They just signed up 3 more missions. They signed up with SpaceX to do them, where they actually take people to the International Space Station. So they now have a total of 4 of these private missions coming up. And each one will carry up 4 astronauts. And these could be private, or well, basically anybody who's willing to pay could go. They could be starting as early as 2022. The visits to the space station would take about 8 days. You'd have a total of about 8 days of the whole trip. So quite a bit longer than the 10 minutes you're getting out of Blue Origin or Virgin Galactic. Now, SpaceX themselves, they've got about 10 missions on the Crew Dragon, which is their capsule for carrying people. Now that includes, of course, the contracts they have to deliver the NASA astronauts, and one also that they have with a company called Space Adventures, which also they were the people that first contracted the very first private person into space, which was carried up by a Russian Soyuz craft. People don't know the actual cost right now in general, but it's usually been reported as around $55 million a person. So if you got if you happen to have that kind of money, you can go to the space station for 8 days. Now they're doing more than just taking up people. They are in the process of building their own commercial space station. They start off attached to the existing ISS, and then they would gradually detach and expand from there. Now, some other projects going on, both of which involve SpaceX and other people. The first fully commercial human flight to low Earth orbit is not one of the ones I mentioned already. It's actually just a separate one sponsored by yet another billionaire named Jared Isaacman. And this was done, we reported on this one already. He did it as a charity drive, so he got people to bid on this. They're paying for the mission through that, essentially. And then, of course, there's the Dear Moon project, which is a bit more ambitious, where it's going into an orbit around the moon. It goes around once and comes back. And that's being paid for by a Japanese billionaire, and that'll be on Starship. So it's a little different. It's not ready yet. So that would be, it wouldn't be before 2023, but it could conceivably happen in 2024, maybe even 2023. The picture on the right here just shows an example of the one of these Crew Dragons from SpaceX that's actually docked at the space station. So, okay. On a little different topic then, we'll talk about some of the disruptive technologies that are going on. There's a company called Relativity Space, and it's been kind of a Wall Street darling. It's gotten lots and lots of private money coming out of venture capitalists, out of Fidelity Investments, and they have their billionaire, Mark Cuban, who's been involved with them from the very beginning. You have to have a billionaire these days, that's just required. They've announced a new rocket called the Terran R. It will be ready in 2024, and what it will be is a fully reusable, which is kind of like what SpaceX would do, but it's all completely 3D printed two-stage rocket. It looks a lot like Starship actually, but it's really more a competitor for the existing Falcon 9 in terms of cargo. It would carry about 22 tons of cargo up to low Earth orbit. Now they already had their previous rocket. They haven't gone to space yet, but they expect to by year end. And it's also 3D printed, although they haven't succeeded completely in doing that yet. But unlike the Terran R, this one is expendable. This is a rocket you just throw away. It's not reusable like most of the, well, like all of these SpaceX ones are. And this one would only carry about 2,700 pounds to low Earth orbit. Now, in terms of competition, that's still about 4 times heavier duty than Rocket Lab's Electron rocket, which would be one of their competitors. They do have contracts. They have about 9 contracts now. So this is real. It is shaping up. Assuming they don't have any glitches, they should be launching by the end of the year. Now, taking a step back, 3D printing is their big thing. Their plan, their goal is to print an entire rocket in 60 days. Now, that includes the engine and the rocket, both. Others, actually Rocket Lab, they print their engines right now with 3D. Blue Origin prints parts of it, but it isn't really just one overall process. You know, they print maybe 400 parts or something. There's a lot of advantages to this. The biggest one is that you just get a lot faster iteration. When you decide to make a design change, you know, you don't have to go back to your supply chain and get everybody to make new things and to test them out. You know, you just basically change the coding a little bit, and you know, the next one that pops out will be your new rocket with a new design. So it's definitely preferred, and that's typically been a role of 3D printing. It's been involved in doing prototypes and that sort of thing. Well, these days the technology is starting to evolve so quickly that everything is a prototype. So that fits the system pretty well. Now, their longer range goal isn't just to print rockets. They also want to print habitats. You know, that could be in space or, you know, on a planet or the moon. So it's an example of a disruptive technology. I mean, it's one that's been around for a little while, but the key thing is it is actually shaping up to play more and more of a role in developing space. So just to show you what they look like, the Terran 1 is the one that's going up by the end of this year. The Terran R is quite a bit bigger, and looking at it, it looks kind of like Starship. The picture on the left would just be the second stage. Okay, so talking more about disruptive technologies, SpaceX has been really the biggest driver in this so far. What is a disruptive technology? Well, typically it's something that just drastically changes things, and usually it's because of drastically reducing costs. And there's this, look at this graph here. This is showing you the price to launch a kilogram of payload into low Earth orbit. And starting back in the 80s, you know, the space shuttle would cost about $85,000. By the end of the space shuttle era, that came down to 26. But then Falcon 1 came along from SpaceX, and that got up below $10,000 a kilogram. And You look at it now around 2020, 2021, they're down below $1,000. So thinking about that, that's a 90% reduction just within the SpaceX lifetime. And even that was almost a factor of 10 below what the original space shuttle cost. So we've gone down by 90%, at least through 2 iterations so far. Now, you look at this curve at first glance, it looks nice, but then you realize it's a logarithmic scale. That is, every horizontal line here represents a factor of 10. So if you were drawing this on a normal linear scale, you would see what looks like a cliff in terms of prices dropping. This is huge. And people actually, at least NASA's goal is to get the price down, even below that. So this has to have an impact, and of course it does. Now, the focus of SpaceX is interesting. They've always talked about reusability. That's been their mantra, and that's most other companies haven't really even gotten much of that yet. But really, they've already gone well beyond that. Their key thing now, if you listen to everything they say, their key is rapid reuse. So, it's one thing to reuse it, but it takes you 6 months to refurbish, or 3 months, or 2 months. They want to get it down to hours. And everything they do is with that goal in mind, is to get it down. Why? Well, for one thing, cost savings. You don't need so many rockets if you can keep reusing the same ones every day. The goal being to look more and more like airplane service as opposed to special one-off kind of things. Those are the extremes. But as I said before about the technology iterations, when you have more and more launches like that, the technology iterations can come faster and faster. And this really applies to not just the launch technology, but it applies to everything. You look, for instance, at the space station. We've had a space station up there for many, many years now, but the actual amount of time spent on experiments, and then when you learn something, how long does it take to get a new experiment up there? Well, before there wasn't that much access to the space station. Well, now there's so much more access to the space station because of more cheaper trips. We can actually start running experiments, learn something, and then send up a new one a whole lot faster. So basically, the pace of everything picks up when costs drop like that. And Starship, actually, as an example, they take reusability further, focusing on faster iterations, which is what you see down at Boca Chica. They keep doing, they just, they do an iteration where they just test a certain aspect of the technology quickly and move on to the next one. You do get it, but the other thing, of course, they're getting will be economies of scale. Same thing with cargo ships. We started getting the ultra-large crude carriers and these very large-scale transport vessels, and everything, basically prices of everything came down. Some other examples of disruptive technology, ion engines. You see them now everywhere on almost every satellite, and also for interplanetary missions like that Japanese Hayabusa mission. It went out to an asteroid and back, and they're going back out and doing all that on tiny amounts of fuel. It's just extremely efficient to use these engines. These kind of things just couldn't have been done a long time ago. You might say the CubeSats were 4-inch by 4-inch satellites, so we're multiples of that. And then technologies to launch them and disperse them, like space tugs. All these things are starting to have a huge impact on the costs and ability to get things into space. 3D printing, we talked about already. Now, future ones coming along, also add, whole changes to relate to the economy. If space solar power becomes a reality, or even a space elevator, all these things start to have a huge impact, because any cost reduction just opens up new possibilities. And that's why there's been so much investment recently, is people see the analogy of the semiconductor industry. You look back at, integrated circuits, you started off with just a couple transistors on a chip, and then Moore's law said you double that capability every year and a half or so. And so the people lived up to that, to Moore's law. But what happened was you ended up getting so much capability and so much new capability every year that you could have whole new industries build up and whole new application areas, just all based on the resulting cheaper computer power. And so what the investors are seeing is that, well, it looks like we're getting this huge decrease just in the cost to get to space. That should enable a whole lot of new things. It's actually come a lot slower than probably a lot of people might have expected. I think it's just a slower moving industry. But the point is, it is picking up the pace, getting more and more like the technology, other parts of the technology industries. So low cost launch is a necessary condition, to make all of this happen. But the reality is we need a lot of other new technologies. What are the big barriers to space right now, besides getting there? Well, one is sustainable life support. The further you get from Earth, the more important it is that it be self-sufficient. Dust is a huge problem. the lunar dust in particular is horrible because it never gets eroded away by wind, so it's very, very sharp edged. But even the Martian dust is quite a problem. It gums up, solar panels and everything else. You need in situ resource use, that is, find things like water, convert it to breathable air and rocket fuel. Artificial gravity, we still don't really know if we can really live on the moon long term, or if we're just going to have a short-term life there because people can't stand the low gravity. And of course, radiation protection. That one's relatively easy to solve, but it's still an issue. There's disruptions that also happen in the business models. I mean, a big one actually is NASA really has done a huge shift, into their credit, I'd say, because they're really buying services now, space as a service in a sense, rather than buying hardware, and buying 1 or 2 rockets you throw away every year. Now they're just buying the service to get to the moon, to deliver some package to the moon or Mars. And they're moving more and more that way. That brings in private investment and really starts things moving a lot faster. Other things they've done, the Artemis Accords, where they're setting up a system so that at least there's a legal basis for using resources in space. It was pretty questionable before. And so as people sign up for the Artemis Accords, that gives private investors much more confidence that they might be able to get their money back by, by mining on the moon or asteroids or Mars. And then even things like in-orbit services, that's becoming a business now. Refueling or moving existing satellites. We've seen some of that in our previous newscasts, where the old geosynchronous giant communication satellites, they run out of fuel, but they're still working. So what you can do is you can go up and attach something else to them and keep on using them. And we get into deep space. Other disruptive technologies are coming along, and that's nuclear thermal propulsion. This is probably is coming back into vogue. It's very interesting because there's a long history of that. NASA actually had funded research back in the 60s and then canceled it in the early 70s. They even had prototype engines. So this is not a brand new technology, but it hadn't been used. And this is really strictly for travel beyond low Earth orbit, going to Mars, or even in cislunar space, they're talking about using it. The key is not using it in Earth's atmosphere. For obvious reasons, you're afraid of, there's an explosion or something. You don't want all that nuclear material running around. So the idea is you'd get it up into Earth orbit, you would never fire the engines, at least, until you got to Earth orbit. There are some advantages to thermal propulsion. The big thing is you get high power and efficiency, and that gives you much, much faster travel. So for instance, you might go from Earth to Mars in 3 to 4 months, rather than 7 to 9. So basically you get the much more power than you get out of chemical rockets, but you get the efficiency more comparable to the ion engines. Those ion engines are very efficient, but they're very low thrust. So this is yet a third solution that offers you the big power when you need it to get around the solar system. Kind of a secondary benefit is that you can then, once you get to where you're going, say you're going to the moon or Mars, you can just take that same reactor and use it for power generation. So you've got your built-in power supply as well. That's especially important as you get further out in the solar system, where the solar intensity goes down. So how do these things work? Well, basically you have a nuclear reactor that heats up a fluid like liquid hydrogen, heats it up very, very hot, and it expands rapidly, and it just shoots out the back like a chemical rocket. But you get at least twice the thrust that you get from the chemical rockets. And also that same expansion actually cools the reactor. So it kind of works out nicely. But apparently they've come up with some new approaches. There was always danger of proliferation. You don't want terrorists getting a hold of this stuff. Well, at least they're not using weapons grade uranium anymore. There are problems with high temperatures and also chemical risks. You're using hydrogen, that tends to cause all kinds of blood metals. So anyway, they're working on solving these problems. This particular picture is one that always shows up in any of the NASA literature on what somebody had hypothesized a nuclear vessel might look like. So this funding goes on. Most people have heard about the NASA funding for this because they've been sending some money to Blue Origin. But actually, there's really at least 3 sources in the government all working on this: U.S. Space Force and DARPA, the Defense Advanced Research Projects Agency. They're all funding it for various reasons. The military is interested, as well as others. The money is going to places like General Atomics, where they're working on the small-scale reactors, which isn't that difficult in a way because you have the model of shipborne ones right now. Blue Origin, most people had heard about, but it's also going to Lockheed and then a bunch of smaller companies that most people probably hadn't heard of. So anyway, this this won't happen for quite a while. They're saying, well, maybe it'll affect Mars missions in 2039. So don't hold your breath for waiting on this, but at least they're getting going on it again. So I think that's a plus. Okay, now we're at the point where we ask people to guess how many launches have there been since the last meeting, which was June 5th. And so this is a chance where you get a little poll here, and you can take a guess as to how many there have been. And I'll remind you that we don't count failed launches. Well, we can count failed launches if they actually got off the launch pad and to go to orbit. So all the suborbital stuff you get out of Blue Origin right now and Virgin Galactic, those don't count. Whereas this one here, the picture you're looking at, this is actually the Chinese going to sending 3 astronauts to their Chinese space station. This is a picture of that rocket taking off. That was a mission. They went to orbit, so they count. And actually, just as a point of interest, when you see that orange smoke like that, the exhaust, what that is partially burned hydrazine, extremely toxic. It used to be very popular as a propellant. It's fallen into disfavor, but they're still using it there. And lots of other rockets use it as well. But it's definitely, people are moving. First they had moved to kerosene and so on. Now actually they're all the newest generation from like on Starship or the Blue Origin engines, they're actually moving to methane, like the LNG basically. Okay, so let's see, how are we doing?
Yeah, it looks like we had about 58% of the people vote, and most of them, like 6 people between 9 and 10, and then 1 person for 14 and 1 person for less than 5. So,
okay, well, it turns out that the 14 or more was right. Now, of course, we actually had 5 additional days because it went from June 5th to July 10th. So, you'd expect maybe a few more. And okay, let me get rid of this. So what were they? I'll just mention the highlights about a couple of them. There are a couple of interesting ones that are launched on June 13th and 15th both by Northrop Grumman, Pegasus XL and the Minotaur 1. These are solid fueled rockets, something you don't see too much of anymore. In fact, the Minotaur ones, these were based on 54-year-old engines from, there's basically, this is plowshares to, whatever it is anyway, some kind of military use, swords to plowshares, I guess, where Minuteman missiles were, were carrying nuclear missiles or anti-missile technology. Anyway, 54 years ago, that thing was built. They just used it. That's the oldest rocket engine ever used to launch anything into space. It still worked. That shows you that technology is really quite reliable. The other one has more refurbished stuff, but basically the Minuteman missile played a big role in all these things. The Pegasus is also kind of interesting because, like the Virgin Galactic and Virgin Orbit craft, it's also launched from an aircraft. It goes up in an aircraft, it gets dropped, the rocket takes off from there. Their big thing is they're trying to show rapid response. They designed and built and launched this thing within a year. So they're trying to, again, in the military uses, they're trying to pick up the tempo so that we can respond to things much more quickly. Let's see. One, of course, highlighting I mentioned is China sent 3 astronauts to their space station. In fact, they've done some spacewalks and they've been quite active up there. So that their project is going on. They have a lot more launches to go for that. Let's see, moving on to these. Oh, there was the Russians sent their cargo to the International Space Station. That cargo, this cargo missions are still split among the countries, mostly US and Russia. One interesting one, Falcon 9 on June 30th. This is the second of their, what they call the transporter series, where they essentially just send up a whole lot of satellites, where they sell batches to anybody who wants them. They put up 88 small satellites, and it costs about $1 million for a couple 100 kilograms. It's relatively cheap, or it is cheap, period. Virgin Orbit, this is one you probably haven't heard too much about. That's different than Virgin Galactic, although it's all owned by Richard Branson, or at least he's the major stockholder of these things. This is another one where it's an expendable rocket, but it's launched from a 747 jet. So all of a sudden, these are back in vogue as well, for at least these small launches. They sent 7 mostly military CubeSats. Remember, CubeSats are the small satellites based on like 4 by 4 by 4 inches or small multiples of that, maybe up to 16 or so. Another interesting one worth mentioning is the Russians continue launching OneWeb satellites, which is actually a British company, a British and Indian company, which is offering satellite services to compete with Starlink from SpaceX. They now have up there 254 satellites. They plan to have maybe 648 by the end of next year. But their commercial internet service should start in a few months. It takes a couple of months for the satellites from the time they get launched to using their own propulsion until they get into their final orbits, and they'll be waiting for that. But the point is, by the end of the year, we should actually have not only Starlink-based internet service, but we should all from the space, but also we'll have OneWeb as a competitor. And that pretty much wraps up the launches. Does anyone have any questions or comments? Okay,
I thought it
in
was
that
a
case,
really good overview. Thanks for putting it together. It's amazing. I mean, every month I'm kind of blown away by what's all going on, and I thought I kept up with everything.
I have one comment.
Yeah.
We had NASA had the annual technical symposium about 6 years ago, and we had a panel of persons like that came from Virgin Galactic and SpaceX. And at the time, the only avenue was through NASA. That was kind of a roadblock getting to space. But Dr. Greg, you presented, just how many new commercial businesses are opening up that roadblock. And I think that's very important, especially in the next couple of years. We're going to see accelerated space ventures.
Yeah, I definitely think so. There's still some rear guard actions being fought by the traditional space contractors, which ironically enough includes Blue Origin, because when they lost that human landing system, the moon landing for humans, when they lost that contract to SpaceX, they've been fighting it in courts, and it was a little scary when I think it was one of the congressmen from Mississippi, or I guess because you have the Stennis base there. They were sort of saying, well, we got to put a stop to this because the government doesn't really own all this stuff anymore, and they should. That was kind of a red flag, but it sounds like things are still going ahead. So that was a bit concerning, though. All right, well, it's probably time to. I'll introduce the speaker, Dr. Kumar Krishan. His topic is going to be technology needs and innovations for space exploration. He's just the guy to talk about that because that's what he does. He develops strategies for research and technology involving NASA, universities, and industry. So he's had contacts in all three. He is currently an adjunct professor at University of Houston, and he's been associated with others, Kansas State, where he graduated, Virginia Tech, Rice, and some others, also honorary professorships in some Indian universities. Key thing is at NASA, he's held numerous key positions, including chief technologist for the Johnson Space Center. He started off as a staff scientist at Lockheed. He's authored 170 technical papers and gotten all kinds of awards, way too numerous to try to list here. For those interested in how people get into space fields, he has his degrees in electrical engineering, master's and PhD from Kansas State, and various degrees before that. So with that, I'll turn it over to Dr. Krishan.